Hello, sixth graders. Today we are going to work on or continue working on our study of kinetic and potential energy by doing a little activity called jumping frogs. Now on Friday we all made our origami model of our frogs, and we were able to test them out to make sure they do in fact jump. Hopefully you were able to make one if you're a distance learner. You can use a variety of paper. This was a cardstock one, which is a little bit harder to fold, but it does have a lot of spring in it. There's a lot of potential energy stored within, a lot of elastic potential energy that is stored within that sturdy cardstock. So when I let go, ooh, this one did a backflip. When I let go, it hops quite far. Okay. So before we start jumping our frogs all around, we have a couple definitions to take care of. Now, I posted this whole assignment on Friday 5:14, jumping frogs. So that's where you're going to go this morning to access your PDF of the activity, okay? And I'm going to help you go through that together. All right, so it says here, let me see if I can make this bigger. Yes, I can. It says here, how does a paper model of a jumping frog demonstrate the conversion of elastic potential to kinetic energy to gravitational potential energy? Well, we've only talked about potential energy and kinetic energy, and so we've got to do some definitions here in order to get real clear on what the difference between elastic potential energy is and gravitational potential energy. Okay, so it says part 1, use an index card to make an origami frog. Your jumping paper frog will be used to illustrate the 3 different forms of energy and the conversions that occur between these forms as the frog leaps in the air and falls back down to the ground. Okay, well, we already took care of this part on Friday, so you should all have 1 or 2 paper frogs in front of you ready to roll. We are going to first off list examples of these different kinds of energy. Okay, it says list 3 examples for each type of energy. Elastic potential energy. Well, elastic potential energy, if you think of an elastic band or a rubber band, that stretches and pulls, right? It kind of deforms its shape in order to store a bunch of energy. The further you pull it back, the further it's going to go when you transfer that potential energy into kinetic energy by releasing it and letting it fly. Okay, so a stretched rubber band, that would be a good example. Think of some others. I always think of like a pogo stick, right? You're pushing down on a spring and then it releases, and all of that potential energy, when you squish the spring all the way down, there's a lot of potential energy, and then when you let it go, it bounces back. Okay, so we could say compressed spring. That would be another one. Maybe you could think of another one. Actually, I'll give you one more, and then if you can come up with yet another, go ahead and write that in on your sheets. Okay, so what about a trampoline, right? We jump on the trampoline, it sinks under our weight, and for a split second there's potential energy before it releases and throws us up in the air. Okay, so we compress that trampoline and release it. Again, elastic potential energy are things that stretch and bend to store that energy. So we'll say trampoline. Okay. Gravitational potential energy. What are some gravitational potential energies? Well, we already talked about roller coasters, right? Gravitational potential energy is when there is an object on top of a hill and it's just kind of teetering there. And if we move it one way or the other on the hill, it is going to roll down the hill due to gravity, right? That's different than compressing a spring or stretching a rubber band. This is something that is set up on a slope that is going to come down the slope. Okay, so a roller coaster is a classic example. Oopsie, I need to type that in there. Roller coaster. Let's think of something else here. Think of my shirt. I got a snowboarder on my shirt. A snowboarder standing with this, or a skier at the top of a hill. Skier on the top of a hill, waiting to go down. Okay, a lot of potential energy there, especially if the hill is really, really steep. That person is going to accelerate very quickly down the hill. How about water in a waterfall, right? Water in a waterfall is at the top of the waterfall at one point, and then it falls down due to gravity. There's gravitational potential energy when it's at the top of the waterfall, and it changes into kinetic energy as it falls. Whoa, that's kind of overlapping, isn't it? Click down here. We can think of fruit trees. Since we just talked about Newton, we can talk about an apple tree. An apple is hanging on a tree, right? Just hanging there. Eventually, that apple is going to fall down to the ground. Okay, so while it's hanging there, it has a lot of gravitational potential energy. It's just hanging out until that stem gives loose, and down it will fall due to gravity. So an apple on a tree. It's another example. Okay, kinetic energy is a little bit easier to think of because it's anything really that's in motion. Okay, so a bird flying is one example. A bird flying, or a ball rolling down a bowling lane. A ball rolling down a bowling lane. Or pushing yourself on a skateboard, or bicycling, or any kind of movement. Okay? Number 2 says, what's going to cause your frog to move? What causes this thing to move? Let me give you the full screen here. Okay, got my frog here. I am going to push down on it. Okay, when I'm pushing down on the back legs, the potential energy is being stored within its legs. When I let go, that potential energy is going to convert into another type of energy. What type of energy is that? What is the energy of movement? Okay, so I push down, I let go, my frog moves due to stored potential energy here, transferring into kinetic energy. Stored potential energy when I push down on the legs, we'll say energy is stored when I push on the back legs as, not legs, legs as potential energy. It is transferred into kinetic energy when I let go and the frog moves or hops forward. Okay. Where does the energy to move your frog come from? Okay, well, we know from the law of conservation of energy that we can't just create energy. When I push down on the frog and I let go, it's still right now when I'm pushing down on it, and then when I let go, it flies forward. Well, where does that energy Where does that energy come from? What do you think? When I push down, it's just like you. If you're going to do a standing long jump, you're not just going to stand straight legged and jump forward, right? You're going to crouch down so you can get some lift. Okay, so that energy comes from pushing down and increasing the elastic potential energy. Oopsie, it did a backflip. How very acrobatic of my frog. Did another one. Wow. All right, so let's go back up here. Okay, so the energy came from pressing down on the back legs of the frog. Okay, that's where the energy came from. All right, now part 2 is asking us to identify the type of energy at each stage of a frog's jump. Okay, and you can abbreviate. We've got 3 different kinds of energy that we discussed up here. Kinetic energy is Ke. Gravitational potential energy is GPE. And then elastic potential energy is EPE. Okay, so what do you think? Remember that the energy of motion is kinetic energy. So anytime this frog is moving, it's going to be kinetic energy. When a frog is jumping, for a split second, it's going to have a little bit of hang time up here, right? Before it has downward movement, and then is at rest again. So see if you can label each of these boxes with either kinetic energy, meaning it's moving, gravitational potential energy, meaning it's high in the air maybe, and it's going to fall down due to gravity, and then elastic potential energy being when it has pent-up energy that's ready to kind of explode outward, or like the rubber bands snapping and going flying. Okay, next page. Number 4 says, as the paper frog rises from A to C, it's talking about kinetic energy is blank and the potential energy is blank. Okay, so what I'm looking for here is either increasing or decreasing. Okay, so as the paper frog rises from A to C, okay, so right down here, from A to C, they're asking, as the frog rises from A to C, what's happening to the kinetic energy? Is it increasing or decreasing here? Increasing or decreasing? And what about the potential energy? Is the potential energy increasing or decreasing here? And why? Why do you think that is? And then number 5 says, at the top of the paper frog's jump, which is point C, right here, the frog is motionless for an instant. Why is that, do you think? Why do you think that is? What's happening here? We had all of this energy here. We used it to get to here, and then it's still for a second. And then what's bringing it back down to the ground? What's moving it from C to E? Okay, that's what we're really thinking about. How is energy transferred from one type to another? We've got a lot of pent-up energy here, goes up into the air, stops for a second, and goes back down. Think about why you think that frog is motionless at the very top. Okay. Number 6, as the paper frog falls from C to E, so this is on the downward part, again, I want increasing or decreasing. The kinetic energy is blank. The potential energy is blank. Is it increasing or decreasing? And is the potential energy increasing or decreasing? And why do you think that is? Okay. And if you're confused about this, just write down what you think. We'll go over these, okay? We'll talk about this in more detail, but I want you to think about this. See if you can answer these questions. And then number 7, at what point does the paper frog have the most gravitational energy and why? Okay, so in that whole jump, where is the frog's most gravitational energy? Where is that at in the series of jumps? Okay, so you can just identify that with a letter right here. And then why do you think that is? And at what point does the paper frog have the most elastic potential energy and why? Okay, then it says, think about the converting from one to the other. Think about the conversion between potential and kinetic energy in your jumping paper frog. Complete the diagram below using the words increasing and decreasing. Okay, so right here, you've got the frog sitting there and loading up ready to jump. Gets up into the air to its highest point, has a little bit of hang time, and comes back down. Okay, so in this first part, from loading up to hang time, is the kinetic energy increasing or decreasing and the potential energy decreasing or increasing? And same thing over here. From the hang time down to the resting position, what's happening? Is the kinetic energy increasing or decreasing? Is the potential energy increasing or decreasing? And then on the very last page, it says, can the amount of energy your paper frog be changed to make it jump at different heights and distances? Well, you made a couple of them with a couple different materials in class. What do you think? Can you change the design of your frog? Can you change the material that the frog is made out of to make it jump at different heights and distances? What did you find to be true? And why do you think that is? Why do you think the potential or kinetic energy changes based just on the material alone, or maybe how you press down on the frog? Okay, number 4, how can you change the potential energy your paper frog has so he will jump further? Think about one change you could make to the paper frog. Think about that. All right. And as you're thinking about that, we'll talk about what in your experiment, it says identify the independent, dependent, and the controlled variables. Okay, well, an independent variable is the one thing that changes. And if you are really going to be thinking about, how does material change how far your frog can jump, then your independent variable is going to be the material used, the type of paper. Okay. What are we measuring between your two models of frogs? That's the dependent variable. What is the thing that we are measuring? We are measuring distance jumped. And the controlled variables, well, if you're really truly doing a good experiment and comparing two different materials, two different frogs with just different materials, then the one thing that should really stay the same, if you're trying to figure out, is it the material that's making it jump further? One of the things that should stay the same is the size of the paper, right? Size of the paper, folding technique, right? We should make the same kind of origami frog, right? To make sure that we're really testing that one variable. If you can think of any other, maybe the surface that you're jumping on. If you can think of any other controlled variables, that would be great, and you can write those in there. All right, down here, you already saw this model. This is your origami directions to make your frog. So see what you can do here. See what you can do with answering these questions that I didn't answer for you. And if you have any questions, we can discuss those in class. If you're a distance learner, you go ahead and fire off an email to me. We'll talk to you soon. Bye.